Hi guys, welcome back to my channel. Before we start with our new math lesson for today, please don't forget to hit the subscribe button and the notification bell for more videos. So in this lesson, we're going to talk about chapter 5 or probability. And under probability, we're going to have the first topic, which is the fundamental principle of counting. For my students, it's from page 280 to 297 of your books. So first, before we go to our first lesson under probability, it's really important to know if what is probability. So probability is a branch of mathematics that deals with a measure of the likelihood of an event. So in this case, we're talking about the possibility before you actually do this experiment or the actual event. Like for example, if you are going to roll two dice, so prior to rolling the two dice, so you're going to measure now if how many possible outcomes are there. Only one of those possible outcomes is correct right after you have done the specific event or experiment. So that is probability. We're not a fortune teller that we are guessing, but we are measuring the likelihood of an event. So example, rolling dice, tossing coins, lottery, deck of cards, and so on and so forth. Now, let's have activity number 2, rolling dice. So when two six-sided dice are rolled, some of the possible outcomes are given below. First is we are going to complete the grid, and then B, how many possible outcomes are there. So this falls under fundamental principle of counting. We are now counting the number of possible outcomes before we actually roll the two dice, or yes. Now, okay, so in counting principle, there are different methods. So if you just want to know the number of possible outcomes, just simply multiply the ways for each event. But if you would like to know the actual list or possible outcomes, there are different methods to use. So the first one is with the use of the tabular method. Example, this one. Okay, so for each die, there are 6 ways or 6 faces. Like for example, in this first die, we have 1, 2, 3, 4, 5, 6. And then for the second die, we have 1, 2, 3, 4, 5, 6. Now, how are we going to know the number of possible outcomes? So we will intersect the first die and the second die. So like for example, in this first row of the first column, we have 1 and 1. Alright, so how did we get 1 and 1? 1 from the first die, and then 1 from the second die. And then, how about under that? We have 2 and 1, 3 and 1, 4 and 1, we have 5 and 1, and 6 and 1. And then in the second column, it's the same. We will start from the first die. We have 1 and 2, then we have 2 and 2, 3 and 2, 4 and 2, 5 and 2, and 6 and 2. Okay, and then for the third column, we will start, of course, from 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, and then 6, 3. And then for the fourth column, we have 1, 4, 2, 4, 3, 4, then 4, 4, 5, 4, and 6, 4. And then for the fifth column, we have 1, 5, then we have 2, 5, 3, 5, then we have 4, 5, and then 5 and 5, and then 6, 5. And then for the last column, we have 1, 6, 2, 6, 3, 6, and then we have 4, 6, 5, 6, and 6 and 6. So these are now the list of all possible outcomes. The first method of the fundamental counting principle is with the use of table or tabular method. Now, how can we easily know if the question is how many? So when we say how many, we're just actually getting the number of possible outcomes. So how are we going to know? You can count them one by one. So in this case, we have 6, 6, 6, 6, 6. So if we're going to add them up, we are going to have 36 possible outcomes. Okay, so teacher, is there an easy way to know the number of possible outcomes? Yes, okay. So just take note that for every die, there are 6 faces. So if we will multiply them, we have 6 times 6. So just remember, guys, that for fundamental principle of counting, we are counting now the number of possible outcomes. Now let's proceed to the next. The second method is what we call the systematic listing. We have the same question. And then for systematic listing, we're going to list down one by one all the possible outcomes. Actually, this is just the same as the first method, which is the tabular method. But in this case, we are actually listing one by one all the possible outcomes. So just like this, we have 1 and 1. So we have a pattern here. We have 1 to 6 and 1 and 1. So it's just the same as the tabular method. But in this case, you are listing them one by one. So they are also 36. So there are also 36 possible outcomes for this method. They must be the same. And the last method is what we call the tree diagram. So for tree diagram, if we have die 1, we will partner it to die 2. So how many possible partners do we have for die 1 to die 2? So for die 1, we have the 6 spaces 1, 2, 3, 4, 5, and 6. Okay, so as you can see, for the phase or first phase, we're going to partner it to the 6 possible ways of the second die. Okay, so same thing with the other 2, 3, 4, and until you reach 6. Now, you're going to get the partner. So we have 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, and 1 and 6. So as you can see, these possible outcomes are just the same with the previous methods until you reach the 6th phase of the first die. Okay, so if you're going to count them, they must be also 36. If they are not 36, they're incorrect. So in this case, tree diagram, you are like branching the first event to the second event, or if there's a third event, fourth event, fifth event, and so on. Now, those are now the 3 ways or methods for the fundamental principle of counting. So let's define fundamental principle of counting. If one thing can occur in m ways, and a second thing can occur in n ways, and a third thing can occur in p ways, and so on, then the sequence of things can occur in m times n times p. So just like what we've done in the previous example, we have 6 phases for the first die and 6 phases for the second die. We just have to multiply them. 6 times 6, you will be getting 36. So that's what we did. That is now the fundamental principle of counting. And then under fundamental principle of counting, we have the several methods to identify the actual list of outcomes, or what we call the sample space. First is the tabular method. So I have shown that to you earlier. And then the second one, we have the systematic listing. And the third one, the tree diagram. So tree diagram is the method that is usually used, okay, so in showing the number of possible outcomes. Now, we have 2 types of events. So first, we have independent events. So for independent events, as you can see, 2 events A and B are independent events when the occurrence of event A does not affect the occurrence of event B. So events A and B are independent with each other. Like for example, if we are going to roll 2 dice, okay, so if we're going to roll 2 dice, the result of the second die does not affect the result of the first die because there are no restrictions that were given. And also, if we're going to pick 2 marbles in a bowl, okay, if we're going to pick 2 marbles, the picking of the first does not affect the picking of the second, and vice versa. So that's what we mean when we say independent events. Same thing if you are in a library. Okay, so if you're going to pick books, so let's say I would like to have math and the other one is English book. So they don't affect each other because there's no restriction. That's why they are what we call independent events. And other thing, let's say for example, there are 2 persons in a park and they don't know each other. Okay, the first person does not affect the second person, and so on. And vice versa, I mean. How about for dependent events? So two events A and B are dependent events when the occurrence of event A affects the occurrence of event B. Okay, now, what do we mean by dependent? Let's say, for example, there's a restriction in picking marbles. Let's say the marbles we have red and blue. Okay, um, you have, for the first event, you have to pick, you have to have at least one red marble. So for the first pick, you should have the first red marble. If it is not a red marble, okay, it's not accepted. So it means the picking of the first is being affected by the other pick. Okay, so if you have two picks, okay, they are affecting each other. So if you have already picked red marble, you're not allowed to pick any more red marble for the second pick. So that's what we call dependent events. So the occurrence of event A affects the occurrence of event B. Let's say in the playing cards, deck of cards. So if the restriction is you have to have two cards, one black and then one red, but for the red cards, you have to pick one face card, at least one face card. So it means that for that restriction, okay, all the other red cards are being affected because you have only 6 options. So we call them independent events. Now, we also have the sample space. Sample space is the list of all possible outcomes. Earlier in the example, the list that you are seeing in the table, systematic listing, and the tree diagram, the possible outcomes there is what we call the sample space of the event of picking or rolling two dice. So we call them sample space. Now, example, how many are there when 2 coins are tossed? Use a tree diagram. So in this case, the problem is requiring us to use a tree diagram in identifying if how many are possible outcomes are there when 2 coins are tossed. So we are going to start. This is the start. And then just remember that from the start, we have the first coin. We also have the second coin below. So how are we going to actually do a tree diagram? So for the first coin, remember that when you are tossing a single coin, there are two possible outcomes, heads and tails. Okay, so heads and tails. And then after that, for the second coin, you are going to partner it also to the two possible outcomes, heads and tails. We are only having 2 coins, so that's why we're finished here. So the possible outcomes are H and H. We also have H and T. We have T and H and T and T. So this is now what we call your sample space. So right? So we are able to have our sample space, and then if you are going to count them, we have 1, 2, 3, 4. So therefore, we have 4 possible outcomes. Okay, so is there an easy way to actually know the number of possible outcomes? Just remember that when we are talking about fundamental principle of counting, we are multiplying the ways of the events. So in this case, for the first coin, we have 2 possible outcomes, heads and tails, and then for the second coin, we also have 2 possible outcomes. So 2 times 2 is equal to 4. So it's just the same. Now, that's if the problem is not requiring you to use any method of fundamental principle of counting. So here's the solution of that. Now, second example, a meal consists of a main dish, a side dish, and a dessert. How many different meals can be selected if there are 4 main dishes, 2 side dishes, and 5 desserts available? So in this case, we are just being asked if how many, and we are not being asked to draw a tree diagram, systematic listing, or tabular in identifying the possible outcomes. So all we need to do here is to multiply 4, 2, and 5 to get the possible meals. So we have 4 times 2 times 5. So 4 times 2 is 8, and then times 5 is 40. So there are 40 possible meals. As simple as that. Okay? Now, we have 30 or rather 40 meals available for this. Okay, so just remember, just multiply, and then we are not being required to use tree diagram or whatsoever. Now, next, example 3. A family has 4 children. Draw a tree diagram to show the possible genders of the children. So in this case, to know the possible genders, okay, we need to draw a tree diagram, and we are required to do that. So just remember, before you start, you can actually visualize if how many possible outcomes are there so that you will be guided in drawing the tree diagram. So in this case, we have 4 children, and biologically speaking, we have 2 genders. We have male and female, or boy or girl. So for the first child, we have 2 genders, and then for the second child, we have 2 genders. For the third child, we have also 2 genders, and then for the fourth child, we have also 2 genders. So if we're going to multiply them, you will be getting 16 possible genders. Okay, now let's draw the tree diagram. So first, okay, we have the first child, we have the second child, we have the third child, and then we have the fourth child. So we have the possible genders. Okay, so let's have this first, second, third, fourth, and the possible genders. Let's start from the first child. For the first child, of course, we will start from the boy or girl if you want. So, and then for the boy, we are going to partner the 2 genders of the second. We have boy and girl. Then for the third, we have boy and girl, boy and girl. And then for the fourth, we are going to partner it also boy and girl, boy and girl. And then we have boy and girl. We also have boy and girl. And then for the girl, of course, in the first child, we are going to partner it also for the second, boy and girl. Third, boy and girl, or boy and girl. And then for the fourth, we have boy and girl, boy and girl, boy and girl, and then boy and girl. Okay, now we can actually list down the possible outcomes. So first, we have boy, 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 boy. Then we have boy, 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 girl. Then after that, we have boy, boy, girl, boy. Then we have boy, boy, girl, girl. Then we have boy, girl, boy, boy. Then we have boy, girl, boy, girl. Then we have boy, girl, girl, boy. Then we have boy, girl, girl, girl. Then if you're going to count them, we have 8. We still need 8. So in the second, we have girl, boy, boy, boy. Then we have girl, boy, boy, girl. Then girl, boy, girl, boy. So girl, boy, girl, girl. Then we also have girl, girl, boy, boy. Girl, girl, boy, girl. Then we have girl, 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 boy. Then we have girl, girl, all girls. So girl, girl, girl. So if we're going to count them, we also have 8. 8 plus 8, we are correct. 16. There are 16 possible genders. So for this, a family of 4 children. So if you have questions regarding this, most specifically to my students, you can ask me. You know how to contact me. Let's have the fourth example. The Exponent Ice Cream Parlor offers the following choices below for their snacks. Suppose you choose a sandwich and a drink. How many possible outcomes are there? So for the snacks, we have hamburger and chicken and egg. And then for the beverages, we have juice and coffee. So in this case, we are just being asked if how many possible, and then we don't need to draw a tree diagram. So all we need to do here is to multiply. We have 3 for the snacks, and then 2 for the beverages. So if we're going to multiply them 3 times 2, we have 6 possible snacks or possible outcomes. Okay, so that's now the answer in this problem. Now let's proceed. Example number 5. A special plate number is made up of 3 letters of the English alphabet, followed by 2-digit numbers. How many plate numbers are possible if A, the letters and digits can be repeated in the same plate number, and B, the letters and digits cannot be repeated in the same plate number? So when we are talking about plate number, there are a lot of possible outcomes for this, but we will just follow the questions that are being asked in this specific problem. So first, we have to identify how many letters are there in the English alphabet, and we have 26. And then the digit numbers, we have 9. So these are the things that we're going to use. So in the plate number, it's a combination of 3 letters and then 2-digit numbers. So for the first question, the letters and digits can be repeated. So the word is can be repeated in the same plate number. So it means now for the letters, we need the first, second, and third. And then for the number, we have the first number or first digit number, and then the other one is second digit number. Now, for the letters, since the word is can be repeated, we can repeat. So for the first character or first letter, we can have, say, 26 choices. And then since we can repeat it in the second, we also have 26, and in the third, we also have 26. And then for the digit numbers, for the digit numbers, we have 10. We will start from 0 up to 9, 0 to 9. And then, so for the first, we have 10 options, and then we have second option. Second, we have also 10 options. And then after that, we just need to multiply 26 times 26 times 26 times 10 times 10. We're going to have an answer. If you can follow, we have 1,757,600. Okay, so possible outcomes or possible plate numbers. So that's for the first restriction. How about for letter B? The letters and digits cannot be repeated. So for the letters, if we have used in 26 in the first character or first letter, we're not allowed to use the chosen letter. So it means for the second letter, we only have 25 choices. And then for the third letter, we only have 24 choices. And then for the numbers, if we use already the 1 for the first digit, so we're not allowed to use it in the second. Alright, so we only have 9. So if we're going to multiply them, you are going to get 1,404,000 possible plate numbers or possible outcomes. Okay, so that's how you compute it. Remember, for fundamental principle of counting, the operation involved is multiplication. Next. Example 6. 5 cards are drawn from a standard deck of cards. 3 are black and 2 are red. First question is, how many possibilities are there? If exactly one of the red cards is a face card, how many possibilities are there? But before that, we have to know the deck of cards. So for the deck of playing cards, we have 52, and then it is subdivided into 2. We have the black cards and the red cards. So of course, we have 26 black cards, and then we also have 26 red cards. And then black cards are divided into 2. We have the spades and clubs. Or we can have clubs first or spades. So for the clubs, we have 13. For the spades, we also have 13. For the red cards, we have heart and diamond. So we have 13 hearts and then 13 diamonds. And then for every division, we have what we call 3 face cards and then 10 digit or 10 numbers starting from the ace to 10. Same as well with the spade, 310. For the heart, we have 310. And then for the diamond, we have 310 as well. So we already know the cards or deck of cards. Let's answer now the question. How many possibilities are there? So 5 cards are drawn from the standard deck of cards. So 3 are black and then 2 are red. So for the black cards, we need 3. First, second, and third. Then for the red cards, we have 2. First and then second. So for the first black card, so we have 26. And then question is, for the standard deck of cards, unlike the tossing of coin and the other plate numbers, Wi-Fi passwords, here, we're not allowed to repeat. Okay, so that is automatic. Because once you have already picked one character in a standard deck of cards, you are not allowed anymore to have it in the second because you only have one specific character. So for the second, now we only have 25, and then for the third, we have 24. Then for the red cards, we have 26 for the first and then 25 for the second. And then just multiply them, and then you will be getting 10,140,000 possible outcomes. And then how about for letter B? If exactly one of the red cards is face card, how many possibilities are there? So in this case, we have black and then red. So for the black cards, we don't have a problem with the 3 cards because we will just be using the same. There's no restriction for the black cards. Unlike the red cards, there's a specific restriction that the first pick must be a face card. So it means if we have 26 red cards, so 6 of those 26 are face cards. So you have options of 6 for the first pick. And then since you are only allowed to pick one face card or one red face card, so for the second pick of red card, you only have 20 number cards. So that's now the restriction for the red cards. And then multiply them as well. You will be getting 1,872,000 possible outcomes. Okay? That's for the cards or playing cards. So just remember, before you can answer a specific problem, you have to understand first, and you have to be familiar with the events that were used. Like for example, in this case, we use cards. Then in example number 5, we are using letters and numbers. So let's have the 7th example. You try. A Wi-Fi password is made up of 4 letters in the English alphabet followed by the 3-digit numbers. How many passwords are possible? A. The letters and digits can be repeated in the same password, and B. The letters and digits cannot be repeated in the same password. So this is just the same as the plate numbers a while back or earlier. So for the English alphabet, we will be using 26, and then for the numbers or digit numbers, we will be using 10, starting from 0 up to 9. So we need how many letters? We need 4 letters and then 3 numbers. Okay, so for the first one, we have letters. Can be repeated. There's no restriction. We can repeat. Now, for the letters, we will start from 26. Since we can repeat, we have also 26, 26, 26 until the 4th letter. And then for the numbers, we have 10 for the first, 10 for the second, and 10 for the third. Then if we're going to multiply them, you will be getting 456,976,000 possible Wi-Fi password or possible outcomes. Now, for letter B, the letters and digits cannot be repeated in the same password. So what are we going to do here? There's a restriction that we cannot repeat. So for the letters, we have 26 for the first, and then for the second, we have 25, 24, and 23. Then for the numbers, we have 10, we have 9, we have 8 for the third. Then if we're going to multiply them, you are going to get 258,336,000 possible Wi-Fi passwords or possible outcomes. So the events that were used here is choosing letters and numbers for the Wi-Fi password. Okay? So for my students, please do this activity, and then if you have questions and clarifications, you know how to contact me. So to those who are supporting my channel, please don't forget, please continue supporting. And then for those who are not yet subscribed, please hit the subscribe button and the notification bell for more videos. Thank you so much and have a nice day.